CodeGeniX Month 2021, which is organized by the IEEE Computer Society Student Branch Chapter of Sri Lanka Technological Campus. The Month of CodeGeniX is a series of continuous programs, and it's the first of its kind in the history of SLTC. Yesterday and last week, we did able to hold the 3 sessions of Road to Codemania Python workshop series, and we are so delighted to tell you that we have successfully held that event with more than 1,000 participants on Zoom and YouTube Live. If you haven't seen those already, make sure to go to the official YouTube channel of IEEE Student Branch of SLTC and take a look at it. So today, you all are here with the final session of Road to Codemania 21, and today, we'll be talking about algorithmic problem solving in HackerRank platform, and also we are going to discuss about coding competitions. Before moving into the session, there's a special announcement to make. As you can see, there is a link in the chat box. If you have any question regarding the session, or if you have anything to clarify, make sure to drop your question in that link. If someone has submitted the same question, please vote for that question without submitting the same question again. So without wasting much time, let's move on to the session. So I would like to invite our speaker for today. He is a recent graduate from the Faculty of Engineering of University of Peradeniya, and now he is in the research field, computer science. He is an enthusiastic about algorithmic programming, and he has won many awards. In algorithmic programming competitions. He is also a lecturer and a research assistant at Sri Lanka Technological Campus. It's none other than Mr. Suren Sridhar.
Thank you, and good afternoon, everyone. Let's move on to the session now. Today's session will give you an introduction to algorithmic programming. So if you are a beginner who's interested in problem solving, or if you would like to get into algorithmic competitions, I hope that this session will provide you the foundation knowledge that's required. The structure of this session will be like this. First, I will give you a basic introduction to algorithmic programming. Then we'll discuss a few problems, their structures, and the solution. Of course, there are tons and tons of algorithms, and I can't cover every one of them within these 2 hour sessions. However, I hope that I could introduce to you some of them so that you could not feel overwhelmed at the first sight. And hopefully, I could also kindle your interest so that you can learn them by yourselves. After discussing a few problems, I'll talk about some algorithmic programming competitions and how you could participate in them and what kind of skill you need to succeed in them. So yeah, without any delay, we'll just go into the session. So first of all, what is algorithmic programming? As the word suggests, there are 2 parts to it, algorithms and programming. Algorithms are a set of well-defined steps which could be used to solve a problem. It's just like cooking a recipe. For example, if you would like to bake a cake, you have a set of raw ingredients, and then you have the output, which is the cake. So there are a well-defined set of steps that you should follow if you would like to convert these raw ingredients into the output, which is the cake. These steps are what we call the algorithms. So algorithm is not only used in something like cooking, but also to solve other problems. It can be a simple problem like finding the average and rank of a lot of students in the class. Or it can be extremely complex problem, like planning your vacation to travel across the US in the most efficient manner. The algorithm required for this would be much more complex in comparison to the simple problem of finding the average. However, to solve any such problem, you will need a predefined set of steps, which is what we call the algorithm. Next, programming. So programming is the process in which you direct the computer to do a certain task using commands which the computer understands. So the commands which the computer understands, we call them programming languages. And there are different types of programming languages depending on the task. For example, you have web development, app development, then you have low-level programming languages and high-level programming languages. However, to solve problems, specifically algorithmic problems through programming, we have a fixed set of languages that we usually use. So the usual ones are C, C++, Java, Python, and Go. But I've also seen people use uncommon ones like JavaScript, PHP, and so on. So in this session, we'll be using Python since the previous ones were also based on Python. So in summary, algorithmic programming is the process in which you solve a particular problem using an algorithm which is implemented through a computer program. The next question you might have is what kind of problem these are. So usually algorithmic programming problems, they have a set of characteristics, and then when trying to solve them, you also have a set of objectives which you must achieve. So first for the characteristics, they almost always have an optimal solution, and then the system is well defined. We'll look at what these are exactly using examples next. But next for the objectives, while you try to solve them, you must try to achieve certain objectives. First one is you must obtain the optimal solution. Next, you should obtain it fast. And third, you should obtain it while not using much resources. So we'll discuss their meanings next. So for this, we'll consider the example where you'd like to travel to different places. In this case, Europe, in the most optimal way. That is, you would like to spend the least amount of money. So there are multiple ways in which you could do this. For example, I can start in London, then go to Munich, Paris, Oslo, maybe Madrid and Lisbon. But if you'd like to travel in the cheapest way, there is always an answer for this. This is what we call the best solution or the optimal solution. So algorithmic problems, they usually have an optimal solution like this, which can be obtained using specific algorithms. But even if you can't get them through algorithms, you can always get them through trial and error. For instance, I can start traveling from London. Then I can go to different places like Munich, Oslo, Lisbon, and so on, and see how much it costs. Then from each of those places, I can continue my journey and go to every other place. And as such, I can, go try to find all possible paths for my journey. And after finding all these paths, I can obtain the most cheapest solution. So we call this the brute force solution. And using this, usually all the algorithmic problems can be solved to get the optimal solution. The alternative is the near-optimal or the suboptimal solution, which is very close to the optimal solution, but not exactly equal. So usually brute force method is when brute force method is extremely slow, and we would like to sacrifice some amount of efficacy to get to the solution a bit faster. We would use this methods we called heuristic methods, which gives you the solution which is close to the optimal but not the optimal solution. However, as I said, most algorithmic problems, they almost always have the optimal solution, and this is mostly in a non-heuristic way. The second characteristic is that the system is known and well-defined. That is, we usually have an idea about the input of the system and how these inputs changes as well. For example, we will know about constraints such as the minimum, the maximum, the range. And we'll also have an idea about all the variables which affects these inputs. For example, if we consider the ranking problem that we discussed before, we will have an idea about the number of students. Usually this is fixed. We'll also have an idea about the subjects. We will also know about the maximum and the minimum marks that can be obtained for each subject. So as you can see, we do have an idea about the entire system. Furthermore, we also, usually the system is also closed and controlled, as in, no other external factors can affect it. So these are the two main characteristics of algorithmic problems. Then you have objectives. So I already obtained what an optimal solution is. And when it comes to algorithmic programming, you should always try to obtain the optimal solution, because near optimal solutions would most probably get you zero marks. Then you need your solution to be faster. This depends on something that we call the time complexity of the solution, which depends on the algorithm that you use. Then your solution should be resource efficient, which depends on something called the space complexity of solution, which is based on the data structure that you use. So even though I used both these terms separately, the time complexity, the space complexity, the algorithmic data structures, they're kind of intertwined with each other, and your ultimate solution complexity would depend on that. So rather than explaining them separately, I think it would be better to explain it through examples. So next we will be going to our first question for the day. Okay, so the first question that we'll be discussing today is the find the sum problem, and you'll be learning about a methodology called recursion. And I'll also give you a few hints about how I would approach a problem and how you will solve it faster. I hope you already have the link for this question, but if you don't, just take a look at it here. It's right down here. It's hackerrank.com/road-to-codemania v2, separated by hyphens. Also, I know that you might have a lot of questions as we go throughout the session, but to keep up with the schedule, I'll just keep on presenting. But please post all your questions either in the chat or in the discussion part of the question. So I'll show where the discussion is. And at the end of the session, we'll definitely discuss all your questions. So before moving on to the question, I would like to give you a basic idea about the platform that we'll be using today, which is HackerRank. Okay. So I hope you can see my screen. Okay. So first, to sign up as a developer, I hope you already have an account, but if you don't, you'll have to sign up as a developer and then fill all this information in here, just the way you would do for an account, and you could create an account pretty easily on HackerRank. Since I already have an account, I'll just skip this step and move on to the question. So this is how a contest would look like. So here you have 4 questions, and then if you want to do some other things, like you can check the leaderboard, you can check how well you're doing right now by comparing all the submissions and such. You can do them. So if you want to open a question, you can just click and it will open. So okay, so this is how a question looks, and you have quite a few parts over here. First, you have the question description, then you have the input-output formats, the constraints over here, and a sample test case. That's at the end of the question. So this is the basic idea of the question. Then you have a few more tabs like submission, leaderboard, and discussion. I'll come to them next when we move forward. So yeah, so we'll start with the description, which is a very good place to start a question. So you have been given a big array containing array A containing n elements, where the ith element is given by AI. So basically, you've been given array A of length n, where the ith element is referenced by AI. There are q queries, each given by 2 integers. Yeah, let me get my pocket. Okay. There are q queries, each given by 2 integers p and q. And for each query, you are required to find the sum of array elements between integers p and q, both inclusive. Can you answer the question? So yeah, let's dissect this question first. So first it says there are q queries, which means you'll have q number of questions, where each question has 2 integers p and q. And for each question, your answer should be the sum of elements in the array A between the indices p and q. Over here it says both inclusive, which means that you should also consider the elements at the points p and q. So I hope this question is pretty self-explanatory. Also, don't miss this. There's a tiny note over here which says P and Q are 0 indexed. So if you are familiar with programming languages, then you would probably know that when it comes to indexing programming languages, it starts with 0, instead of 1. So that's about the description. So if you did not understand the description, you could even proceed to the input format and then try to get a better idea about the question. So if we read the input description, it says the first line contains 2 space-separated integers n and q. The second line contains n space-separated integers ai for I between 0 and n-1. Then the next q lines each contains q space-separated integers p and q. So all the input that you need is defined here. First, it will say about the length of the array and the number of questions that you're getting. then it will give you the array itself in the second line. And in the next q number of lines, it will give each of your questions as two integers p and q. Then for each of, if you go to the output form, we'll just skip constraints for now and go to the output format. So if you go to the output format, it says that you should output q lines denoting the sum of array between the indices p and q. So I hope this is also kind of self-explanatory. Basically, you should take all these inputs and print the sum of elements for each question. But still, if you are unclear about the question, there's always the sample input which you can check to get a better understanding of the question. So yeah, we'll just compare the input and the formats and the sample that's given. So it says the first line will contain two space-separate integers, n and q. So in this case, it's 5 and 4. So n is equal to 5 and q is equal to 4. Then it says that the second line contains n space-separated integers ai. So the second line would contain the array, which should have n elements. And in this case, it has 1, 2, 3, 4, 5, exactly 5 elements. Then we'll have q lines, each containing two space-separated integers, which represent p and q. So in this case, q is equal to 4, so you'll have 4 lines, and each of these lines will have 2 elements, p and q. Sorry. Now for each of these queries, you should mention the output, which is the sum of the elements between these two indices. For example, if you take the element between 0 and 1, in this case, that's 3 and 4. So this is the 0th element, this is the first element. So the elements between that range is 3 and 4. And the sum of that element is 7. So if you go down over here and read the explanation, it will basically exactly say what I just explained. So it will talk about the p and q values, the n value, the capital Q value, and then it will say that the sum between this range is 7. Similarly, for each other test case, we can still verify it. For example, the next query is 2 and 3. And for that, the summation is given by, so this is the second element, this is the third element, and the summation is 11, which is printed out here. The third query has 4 and 4, so it starts here and ends here, and the summation is 7, which is given out here. And then the last query is between 0 and 3. So that is 0, 1, 2, 3, all these elements. And the summation is 6 plus 4, 5, 3, 18, which is given here. So as you can see, I hope you understood the format of this question. Basically, you will be given an array where you have certain numbers. Then you will be given few questions where for each question, you should find the sum of values between the two indices. At last, you have certain constraints. These kind of explain how the variables would change in the question. So we have a few variables, n, q, ai, p, and q. So it says n varies between 1 and 10 to the power 4. So the largest array that you can have has a size of 10,000, 10 to the power 4. And the smallest array is 1. Then you have q queries. So the maximum number of questions you can have is 10 to the power 7, and the minimum is 1. So you'll at least have 1 question. Third, it gives an explanation about the range of the elements within that list. So the value of each element can vary between 0 and then this explains about the range of the query values p and q. So p and q, they should both be between 0 and n minus 1. It's kind of self-explanatory because if you're considering the indices, they cannot go outside the list range. And then it also says that p should be less than or equal to q. So p cannot be higher than q because then the start point will be greater than n point. So to verify it, we can just look at the sample input. So in this case, n is equal to 5 and q is equal to 4. So the first two constraints are indeed true. Then you have the list over here where the elements are 3, 4, 5, 6, and 7. If you compare it with the third constraint here, you know that every element would satisfy this condition. And then you have all the P and Q values. It says that this should be between 0 and n-1. So n in this case is 5. So all the values should be between 0 and 4. Here all the values are indeed between 0 and 4. And then P should be less than Q. So the first set of values in this, the first column should be less than second column, which is also indeed true. So I hope you got an idea about the input, output, and constraints. And if you go back and remember my definition of a algorithmic programming problem, I said that it should have two features. One is that it has an optimal solution. The optimal solution is given over here, which means it does exist. And the second condition is that you should know about all the inputs, outputs, and the constraints usually. So in this case, we know that there are a fixed number of inputs called N, Q, AI, P, and Q. There are no other external factors which affect it. And we also know the range in which these variables can change. So that is given by this particular constraints. So this kind of goes with the definition of how I defined a algorithmic programming problem. So now we'll come to the solution. Okay, so just to reiterate the question, we have been given an array of length n, and then we have q questions where each question wants us to find the sum of the element between two indices p and q. The question is pretty simple, and so next we'll go to the solution. The solution is pretty much straightforward as well. So initially we make the total value to 0, and then we can start by iterating through the list from the point P to Q, and keep on adding the value of every element to this particular variable called total. And finally, once we come to n, the total value would have the answer that we need. If we write this as a pseudocode, it will look something like this. So yeah, before solving the problem, the first step is to actually read the input. So we'll read the first two integers given to us, n and q. Then we'll have to read the list that's given to us. The list, I'll store it as a. Then we'll have a q number of queries, and for each query, I read the two values p and q. Then I will find the answer using a function called SumArray, which takes a, p, and q as the input. So the function SumArray can be defined like this. So initially, we initialize the total value to 0. Then we iterate throughout the list between the range p and q. So we name each an element I. Between the range p and q, we call that element I. Then we add this I value to the total and finally return the total value. So next, let's actually code this in HackerRank. So this is the only time I'll be coding. We expect that you should be able to do the other things by yourself based on the knowledge that you gained from the previous Python sessions. I'll also show you other things like how to submit a code, how leaderboard and discussions work. And yeah, we will start. So as I said, the first step should be to, read the input. So yeah, through these first two lines, I can read the input and then convert them to integers. Then this line, it actually reads the array that's given to me. Then I iterate through q number of queries. And for each query, I read the values p and q. And then the answer should be done using a function called SumArray, which takes a, p, and q as the input. So this is exactly similar to the pseudocode that I just showed you. And next, we'll actually code the SumArray function. So the function should go on top of this, and the function looks like this. Okay, so the function SumArray takes three inputs a, p, and q. And as I said, we initialize the total value to the variable called total to 0. Then we iterate through this list from p to q. So in this range, we want p and q to be inclusive. And if you are familiar with Python, you should know that the end index should be one higher than the last element that you want. So in this case, q is the last element that I want to include. So I make this q plus 1. And then I add the total value over here, total equals total plus I, and finally this function returns the total. And once the function returns the total, so the SumArray function, I can print that as the answer. So if we look at the pseudocode, it was almost exactly the same. So I initialize the total variable and I iterate through this loop and then I return the total. So something that you might notice here is why I have this node called use built-in functions. So Python has a built-in function to actually do this sum value. So you could actually use that instead as well. In fact, in most cases, it's recommended. However, I coded this by myself. Even if I had used that, it's perfectly fine. Okay, next we'll submit this answer and see if our code works. So now that I have the answer, the first button that I will usually click is the run code button. So the run code button, it runs this particular code on the test case that's given to me, the sample test case, and it says if my answer is correct or wrong. So in this case, my answer is correct, and just congratulations. So as of now, I have just made sure that my code works for the test case that's given to me, but apart from that, there are various other test cases which are not given to me. So in order to test my program on those test cases, I should click the submit code, and then the code will, run using this unseen test cases, and I could see if my code works for the, all these hidden test cases. So just to give you a basic idea about this, so first you have the input over here, which is the input of the test case, the same value as this one. Then you have the output, which is, it says U output, which means the output that was obtained through this code is over here. And this is the expected output, which is the sample output I was given over here. So in this case, since both of them are the same, it says the test case is correct. So since I'm quite confident that my methodology is correct, I will try and submit it. By the way, usually when submitting it, even if your answer is wrong, most of the cases there will be no penalty. So unless the a particular competition or challenge it incur some penalty, in general, most of the problems in HackerRank, they don't have any such penalties. So I will submit this, and let's see. So my code pretty much worked for this test case 0, which I already know. So this is a sample test case, but then again, there are 3 other test cases which works, and now it's running for the rest of the test cases. So it says runtime error. It says processing over here, which means it's not complete yet. That's because there's one more test case. It's run. Okay, so actually my code did not work. And if you want to know the error, you can just go over one of these test cases and it will say that it was terminated due to timeout. But before going and actually seeing why this happens, I'll just explain this tab. So over here you have the submission tab, where you can see the reason code that you've submitted. If you you go somewhere else and come back over here, you can see that all the submissions that you have previously made. So if you need the code for some older submission, you can click view result and then open that code using this open data button. Then discussion is a forum where you can post all the questions. So if you go over here and you can post any question that you want, and then so as I said, we cannot answer questions right now. So if you just post them to this discussion forum, we'll try our best to answer it as soon as possible. Okay, so now we'll see why our code failed. So the reason for it is that it was terminated due to timeout. So if I go back to my presentation and back to here, it says that one of the objectives of algorithmic programming problems is to obtain the optimal solution. But in addition to this, I should also get the solution faster, and I should also be resource efficient. So in this case, it says timed out because I took more time than which I was allocated. So in this case, the problem is that my code is not fast enough. So next, we'll have to analyze exactly why it's not fast enough, or what I mean by fast. So this comes in terms of something we call time complexity and memory complexity. These are terms I introduced earlier, but I didn't explain it. So time complexity refers to the amount of time taken to run a code, and it's usually measured in terms of the number of operations that we do. And space complexity it refers to the amount of memory that we used, that the program uses, and it can be measured in terms of the number of variables that we use simultaneously. So for instance, if we go to this particular function over here, okay. So if we go to this function over here, sorry, the sum array function. So over here you are doing, so first in this line you are doing one operation, then you are iterating throughout this list. So you iterating throughout this list, and then for each of the elements you do one operation, and ultimately you do one final operation. So first you have one operation here, and over here, since you are doing q minus p number of iterations, this thing will be repeated for q minus p number of times, and finally there will be one. So total is q minus p plus 2. So we'll just ignore the 2 for now and say that the time is q minus p. As for the space complexity or the memory, we are introducing two new variables. One is total and the other one is I. All the other variables like come out from the function, like they already initialize outside, so we don't worry about them here. So the time complexity, time or the number of operations for this function is q minus p, and the number of variables required is 2. However, like even though we can measure this in terms of an actual number of operations and actual variables used, usually we care about the order of the function. So the order of the function is something that we can interpret as the worst case scenario in algorithm, and this is defined using a notation that we call big O notation. So I don't want you to confuse with all these terms. So you can simply think of big O notation as the number of operations that would happen in the worst case scenario. So for example, for this particular function, the worst case would be when q is equal to n minus 1 and p is equal to 0. In this case, you will need n number of operations. So as such, your complexity, the time complexity, can be given as On. As for the memory doesn't depend on actually the size of the variables. It's like 2 elements which are always constant. So the memory is 2, and like to show that it's constant, we don't say O2, we just say O1, because O1 says that the memory would always be constant. It doesn't vary with the size of any arrays that we are given. So when we come out of this function and we look at the time and the memory complexity of our entire code, and you can see that we are first reading 2 integers n and q, then we are reading a list A. So over here we have 2 variables that we are using, and then over here we have 1 variable that we are using, and then for each query we read two values p and q, and then call the function. So a majority of the memory would be allocated to this particular list A, because all these variables need just one memory location. So the memory complexity would be On in this case, because n is the size of that we are given. As for the time complexity, we saw that this particular function, it in the worst case has a time complexity of On. Now, since we have q queries, we'll be repeating this function q times. So it will be q into On, or if we actually calculate this, it will be OQN. So yeah, just remember these 2 values. So one is OQN and the other one is On. Now, usually in HackerRank, so the time and the memory complexity can go to the maximum of 10 to the power 9. So this is not like a hard and set rule, but an easy way to think of this would be like if my code goes somewhere close to 10 to the power 9, then my code is obviously going to fail. So we'll see if that does take place in this case. So over here, if I go back to the problem, if you remember the time complexity of our problem, it was ONQ. So in this case, n is 10 to the power 4 and q is 10 to the power 7, which means ONQ, it goes to somewhere around 10 to the power 11. If you remember, the limit that I said we can't go to was 10 to the power 9. So this is like 10 to the power 11 is 100 times more than 10 to the power 9. So which is exactly why my code fails, It says timed out because I'm supposed to get this answer within 10 to the power 9 operations, but my code goes 10 to the power 11 operations. As for memory, it's not an issue because if you remember the memory complexity, it was On. And in this case, n is 10 to the power 4, and I can use up to a maximum 10 to the power 9 operation. Sometimes you can only go up to 10 to the power 8. But in this case, we are only going up to 10 to the power 4. So the solution for that part is okay. So next, we should analyze why this happens. But before that, so the reason for this is because our problem is not optimized yet. and we'll have to optimize it using a particular technique called dynamic programming, which I will introduce next. But before going into that, I would like you to think a bit, and if you can solve it by yourself, it would be great. But we'll skip to a much easier, because the dynamic programming topic is a bit more complicated. So we'll skip to an easy question and try to solve that, so that you'll have a much more easier time in solving other problems. So it would be easier, for you to follow maybe a similar pattern. So first I'll start with the description. However, since I already know the question, I'll just summarize what the question wants us to do. So it says that a teacher basically wants to give candies to students in her class based on the marks that they obtain. So I should follow 3 particular rules that are mentioned here. So first, I should give a high number of candies to student with high number of marks and low number of candies to student with low marks. The second requirement is that I give equal number of candies to students with equal number of marks, and then the third requirement is that every student must get at least 1 candy. So if I had infinite number of candies, I can do this in multiple ways, as in I can just keep on giving more and more candies to the person with the highest amount of marks. However, finally it says rule as well. So over here it says that Anna wants to buy the minimal amount of candies by satisfying these conditions. So I have a basic understanding of question. So I will be given an array of marks of all the students, and then I should give candies to them while following these rules, and then I should find the minimal amount of candies that I should give to them. So finally, the question is, given the marks of all the students, can you help Anna find the total number of candies which she must buy? So the answer for this question is indeed the minimal amount of candies, and once I know about the allocation of each and every person, then I should be able to find the minimal amount of candies as well. So I think this problem is pretty clear. I don't have any confusion in this regard, but still maybe I'll encounter some problems when I'm going through the inputs and outputs. So I'll just continue for the rest of the part. But as for now, everything is pretty much clearly explained. So then I will go through these sections, but instead of going from top to down, I usually prefer to compare this input format with the sample input, so that I'll get a clear idea about the variables that I will be given. So it says that the first line contains an integer t, which represents the number of test cases. So in this case, the first line is 2, which means t is equal to 2. Then it says each of the following 2 t lines has the following format. So I will have 2 t lines, 4 lines, which are here. That's also correct. Then each test case is described by 2 lines. So now I know that for each test case, I will have 2 lines. So this is probably the first test case, and this is the second test case. And in addition to this, I would also know that I probably have 2 answers, one for each test case. So this is the answer for the first test case, and this is the answer for the second test case. So although I did not read this output format yet, I probably know that these 2 are the answers for these 2 test cases. Okay, so next, let's see what these test cases explain. So it says the first line contains an integer n, which represents the number of students in the class. So this is the first test case. So this is probably the value of n. So by initially reading the question, I also know that I will be given the marks of certain students, probably as an array. So usually when an array is given, it is explained in 2 lines, where the first line says the length of the array, and the second line gives the array itself. So in this case, the first line 6 is probably the length of the array, whereas the second line, this 5, 8, 5, 3, 1, 10 is the array itself. So although I did not read the rest of the input, I kind of assumed that this is what it would look like. So let's just check that. So over here it says 5, 8, 5, 3, 10. It has 6 elements, which is probably the one which is given over here. And over here, the second test case, I have just 1 element 0, which means probably it's a single element array. 0 with 0 as the element, and 1 is the length of that. So probably that's what these 2 mean. But still, I will just read the last line as well. So it says the next line contains in space separated integers AI, which represent mark. So yeah. So indeed, this array gives tells me the marks obtained by each student. So there are 6 students, and the marks of each of these students are given here. So yeah. So just to reiterate the question. I'm given the marks of a fixed number of students as an array, and now I should allocate candies to these students based on these rules, and then I should also make sure that they are minimal, and then as the answer I should print out the minimal number of candies. So in my mind, I have a particular solution. I'm not sure if that's exactly correct, but just to confirm, what I can do is I can go to this explanation that's given by the problem set, so that I can say my understanding of the question is correct. Okay, so there are first few parts over here which explains the input. So here it says t equals 2 and n equals 6. So it explains this and this, and this. Then it says that this has the marks of all students. So my understanding of that is correct. Then for the answer, in this case, the minimal amount of candy allocation, which follow the rules is as follows. So over here, I have certain number of values and then some candies. So I'm going to probably, I'm at the moment, I'm just interpreting this as follows. So this is probably the mark of the student, and this is the candies that they have been given. So just to confirm that, I will check this with the input. So over here, I have 5, 8, 5, 3, 1, and 10. So these are the marks. And if I go over here, I have the same marks in this column. So 5, 8, 5, 3, 10. So my assumption was correct. So over here, I have the marks, and over here, I have the candies. So if I go through these values, I can see that 1 candy was given to the person with the lowest marks, which is 1 mark. Then for the next student with the lowest marks, which is 3, he or she was given 2 candies. Then the next lowest mark is 5, and there are 2 students with that particular mark, and they have both received 3 candies. So 1 candy for the lowest, 2 candy for the next one, 3 candies for the next highest, and then 8 is the next lowest one, and he or she has got 4 candies, and then the person with the highest mark has gotten 5 candies. So you might have also observed that instead of going from top to bottom, I followed a very weird path. I went from here to here, then here. That's because I kind of had a solution already in my mind, and I was just checking if my solution was, kind of correct. So in this case, since I need to find the minimal amount of candies, the solution in my mind was I can just give the lowest amount of candy to I can start with the student with the lowest amount of marks, and I can give them the minimal amount of candy. Then after that, I can keep on increasing the number of candies to, all the other students with higher marks, based on their mark allocation. So my solution, my approach seems kind of correct. And to verify it, I can even go for the second test case. But over here, I just have, an element with just an array with just 1 element. And so I just have to give 1 candy. And probably that's the answer I have over here. And I think this explanation talks about this. So I think I have got a pretty good understanding of this question. Like, there's nothing very complicated over here. And I think I have a rough idea of the answer as well. So probably I can try, testing that out. You might have also noticed that I just skipped over these constraints, because in this case, I didn't come across any problems while understanding this question. Usually, I would come back to these constraints. There are certain cases which I would, particularly for this constraint. One is when there are multiple solutions that come up to my mind. It would be better. So some of these solutions would be much more easier and fast to code, but they would be pretty much slow. While some solutions are faster. So if I have 2 solutions, one which is slow and easy to code, and the other one is hard and fast but hard to code, then I would come back to this constraint to check which one I should probably prefer. Another case where I would check this constraint is when I don't know the answer. So by looking at this constraint, I can get a slight idea about the answer. The third case is when I try to submit something and it goes wrong, then I would come back and check the constraint. So in this case, I don't have any such issues yet. So what I will do is I'll just go to the solution. So as I said, the most easier way to approach this problem is in this following method. So first I sort all the students from the lowest to the highest mark. Then I just give 1 candy to the student with the lowest mark. Then since I have sorted, the next student should definitely be higher or equal. So I go to the next student And if he or she has higher marks, then I should give them one more candy. That's like if I give one candy to student with lowest mark, I should give 2. So if I give C equals 1 candy to the first person, I should give C equals C plus 1 to the person, so student with the next highest mark. However, if that's not the case, like if the next student has equal number of marks, then I don't increase this value of C. I keep it the same, and I just give C amount of candies to the student. So if I go back to the example over here, that's what has happened. So over here, when going from here to here, so I go from here, I went from here to here, the marks had not increased. So I keep this value of C the same. So for this student, C is equal to 1. Then I go here, and since he or she has higher mark, I give 1 more candy. Then I go to the next person who has more marks, so I increase the candy. So then I went over here, and now the mark is not higher, so I kept the amount of candy the same. So probably this solution looks okay. And next, this solution looks okay. So next, this particular technique. So this is something we call the greedy algorithm. So the solution is very straightforward. Anyone can think of this, but this is a particular name called greedy. So greedy is an algorithm where at each step we make the decision greedily, as in we search for the local optimum, and we hope that this would lead to the global optimum solution. So in this case, the global optimum solution is like the minimum amount of candy. So ultimately, I need to find the minimum amount of candy. So if at each step I assume that if I give the least amount of candy to each student, then I kind of assume that I would end up at this global optimum. So the local optimum is me giving the minimum amount of candy to the student with the lowest marks, and then moving on from there. And I kind of assume that I would reach the global optimum. So in this case, the greedy algorithm actually works pretty good. So I don't have to worry about anything else, and I can go to the coding section. So this is not the actual code. You have the pseudo code over here. So first, as you would remember, we have to read the particular integer t, the number of test cases. Then for each test case, I should read the array A, which has the marks of all the students. And then for each of these arrays, I should get the answer by passing it through a function called candy. So next, what does this function candy look like? So first, as I said, the first step is sorting. I sort all the values from lowest to the highest. And then I give 1 candy to the person with the lowest mark. So that is C equals 1. Then this is the total is the final answer that I'm going to return. So I make the total C because I have already given 1 candy to the person with the lowest mark. Then I go to the next person. So for each and every mark M in X set the lowest mark. So I just ignore the first one with the lowest mark and go to every other person. And then if the next person has marks more than the previous mark, I would add 1 to C. So like if the first person had 1 mark and the second person had 3 marks, if you remember correctly, we added 1 to C and gave 2 candies to the second person. If not, I keep C the same. And finally, since I've given this candy, I add the number C to the total value and then return the total to the answer. So that would get returned and will come over here, and that would be the answer. So you might be wondering what this sort function is. So there are many ways to do sorting. In fact, I'm not sure if you're familiar with them, but there are different sorting algorithms like search sort, insertion sort, bubble sort, and there are a lot of them. And I may not be able to explain all of this within this a lot of time. But lucky for us, Python already has an inbuilt sort function. So one point that I would always emphasize is that if there is an built-in function that's provided by Python itself, you should always use this. Because the way we code, if we are coding the sort function by ourselves, it would be in a high-level, using high-level operations, and it would be pretty much slow. Whereas the built-in function in Python, they operate at much lower level, which means they have been a lot more optimized. And as such, these functions are much more faster than what we code manually. So unless you know that your solution is obviously going to be better, if you are going to implement an algorithm that's already implemented by the library itself, then it's always a good case to use that. that being said, sort is one of the important algorithms to learn. So I do suggest that you take a look. In fact, by knowing all these algorithms, you can make slight modifications and solve different questions in different ways. I'll post the link for that in the discussion, so you could take a look at that once you have solved this problem. But for this particular example, Python already has a sort function. You can Google search and get an idea about that. So next, if we go forward, we can discuss about the time complexity of this. So if you can see here, I have removed a lot of parts to make this a bit shorter, but the idea is the same. So I initialize two variables and then iterate to the list to get the marks of every person. And then if the marks was less, I did something, else if it was equal, I did something, and finally I added this value of candies to the total. So this is just a shortened version, but basically the idea is the same. So over here you can see that so the yellow parts are the time complexity. So sort has a time complexity of n log n. The explanation of this is quite complicated. It depends on the implementation. So I will post the link for this in the discussion, as I said, and you could take a look at that whenever you want. Then for this part, if for marks, so I'm iterating throughout this list, which has n elements. So for each of these n elements, I do two operations. One is, I increment c and then add c to the total. So I will have 2n number of operations usually. So this entire function, it has 2n plus n log n number of operations. But from both of these, the significant one is n log n, which means as we discussed, when we go to this big O notation, it comes to n log n. So ultimately, this candy function has a time complexity of n log n, which is what we have over here. So, and then we call this candy function for each test case t. So this would be t into n log n, or t n log n. As for the memory, over here, we are not using any new variables. We are just using a few variables like total and c. The main memory requirements comes over here while we are trying to save a particular list called A. So there will be a number of elements in this list. So this would require a number of memory elements. So as such, the memory complexity of this problem would be O(n). So just keep these two values in mind, n and tn log n. So if I go back to the question, you can see that t is 100 and n is 10 to the power 4. So tn log n would be something like 5 into, no, it won't even be 5, it will be a very low number. It will be something between 10 to the power 6 and 10 to the power 7. The memory complexity is O(n), so that's something like 10 to the power 4. So as I said, 10 to the power 9 is like the hard limit, or not the hard limit, the limit in HackerRank. So in this case, the solution which I have proposed would work. So I don't have to worry about this. So you can just try coding this in Python based on what we have learned, and you can see for yourself if it works. So before going to the final question, we'll take a short break. We are already past the half-hour mark. So while you take the break, I will give you a short introduction about this programming competition as I promised, and hopefully that will prepare you better when you are attending these competitions. So this presentation is going to be on programming competitions specifically. So I'll give you an introduction on what they are, the skills that you'll require, and how you could achieve these skills. A tiny note is that this session is mainly targeted towards Sri Lankan undergraduate students, and as such, most of the information that you'll find would be relevant in a mono-local context. So first, to clarify some confusions about these competitions, there are three main types of computer science competitions, namely hackathons, data science, and algorithmic programming competitions. So hackathons are the most common type of competitions. These are product development competitions where you go and pitch an idea for a particular product, and usually it's followed by a demonstration of this idea. Finally, you are ranked based on the viability, profitability, novelty, and many other factors like this. So these competitions can sometimes be themed as well. For example, in some cases, you will have to solve a problem in a given domain. In biomedical hackathon organized by University of Moratuwa, Brainstorm is a good example of that. Then there are some hackathons where you will have to use a particular technology, like the Dialog NBI hackathon. However, the overall idea is that you should have a specific idea for a viable product, and you should pitch this idea to the judges. So there are many such competitions, both locally and internationally. So locally, you have competitions like HackX, RealHack, iHack, IntelHack. So these are organized by universities. In addition to that, there are competitions which are organized by other entities like Find Your Fair and Dialogue. There are tons and tons of them. So if you'd like to get more information about hackathons, you could either go to www.hackathons.lk, which is a local website, or to get more information about international hackathons, you could go to hackathoninternationals.com. So both of these are like information aggregators, which means they don't organize hackathons themselves, but they have information that you would need to compete in these competitions. But today's topic is not about hackathons. So moving on to the next type of competitions, these are datathons. So datathons are competition in which you are given a data science problem and a particular data set, and you should solve the given problem using the data set given to you. Unlike hackathons, you are usually given a predefined problem, and in addition to this problem, you might be given some additional task, like developing a marketing idea, or getting it to actually viable product. But this kind of requirements, they vary depending on the organizers themselves. So in the local context, there are quite a few competitions, not as much as hackathons, but Datathon and Hackstack, these are two datathons organized by the universities in Sri Lanka. Then there are also datathons organized by other entities like the Dialogue Datathon. In an international scale, Kaggle is probably the most famous one. It's technically not a datathon, but Kaggle organizes multiple data science competition, on a weekly basis. Then coming on to the final type of competition, which is the competitive programming competitions, which is our focus of the day. So competitive programming competition is a competition in which you solve algorithm problems. In addition to obtaining the correct solution for this problem, you should also do it while it adheres to certain constraints like time and memory. Based on your ability to solve algorithmic problems, you will be given points and then ranked based on the points that you get. So this is a sample problem from a competitive programming competition, which this is obtained from the website called CS Academy, which is the platform in which IEEE Extreme is organized these days. So this is the way in which a problem is presented. So first of all, you have a problem description, and then the input and the output. You can use this information to interpret the problem. Then you have some examples which you could use to get a better understanding of the problem, or you can also use to test your code to see if it's a problem. Finally, you will also have some constraints, and as I told, in addition to getting the correct answer, you should also make sure that your code adheres to these constraints. So by solving several problems, you'll be awarded points, and finally you are ranked based on the points that you obtain. So this is the general idea of competitive programming competitions. The requirement might slightly vary depending on the organizers, but this is the basic idea. So next, you might be wondering who I am, based on things I said. So I am an algorithmic programming enthusiast. I have participated in quite a few coding competitions like IEEE Extreme, Google CodeGeniX, and ACES Coders during my undergraduate years. Most notably, our team, I was placed in top 2 for like 3 consecutive years. The team Bytecode from University of Peradeniya, it was placed in top 2 for 4 consecutive years. And the ranking you see here is our ranking from the year 2017, if I'm correct. If you'd like to know more about us, you can go to my personal page at 73141.github.io, or you can go to this the team page, which is teambytecode.com.github.io. So yeah, as you can see, even though I'm not an expert in this field, I hope my opinions would be quite helpful to you in the future while you're preparing for competitions. So the first question that most of the people have is why someone participate in competitive programming. So there are quite a few reasons. First one is that it improves your problem solving skills. For example, if you would like to develop a platform like Uber for efficient ride sharing, then you would need a fundamental knowledge of algorithmic programming. Then another advantage is that obviously it improves the problem solving for programming skills, because you will be using multiple programming languages to solve these problems. Then it will give you a competitive edge when hiring. For example, companies like Google and FB, they have their own programming competitions. So by participating in them, it will be a plus point in your CV. However, in addition to them, interviewers, they commonly use algorithmic programming competition as a measure when conducting interviews. So, if you are familiar with these problems, you would have a comparative edge compared to other interviewees. So finally, of course, you have awards and recognitions. In the local context, the prices can vary somewhere from 75,000 rupees to 100,000 rupees, whereas in global context, you'll get much more prizes. So next, what do you need to know in order to succeed in them? So in general, comparative programming competitions are said to be a combination of mathematics, programming, and creativity. So these are supposed to test your problem-solving skills, and these are usually advertised in such a way. So most of the people expect the ratios between this to be somewhere like this, where you need most of the knowledge comes from programming, and then you need some mathematics as well as creativity. This ratios actually vary depending on problem setters, but this is how a competition is usually advertised. So even though this is how you expect it to be, or most people expect it to be like this, the reality is indeed quite different. So in reality, a major component comes from practice. In order to succeed in this competition, what you need is rigorous practice. And once you do enough questions from different algorithms and different platforms, you can train yourself to think in a particular way. Once you train yourself, then you can be quite a good comparative programmer. So next, how long should you practice and how can you practice to train yourself to think in this way? As a beginner, this can be quite a tedious process because there's a lot of information online, and when you come across this, you might probably be overwhelmed. And as such, so we can divide your expertise into 3 levels, and depending on your expertise, you can have different beginning points. So if you're a beginner, and if you are not familiar at all with programming or algorithmic programming, then the first step is to practice. By practicing using different online platforms and different algorithms, you should first make yourself familiar with all these concepts. So once you are quite familiar with them, then you can think of going to the next stage, which is the moderate level, where you can participate in local and online competitions. And once you feel that you're even confident and comfortable with that level, then you can advance to the next level. It is the advanced level where you can participate in global competitions. So there are a lot of popular online platforms in which you can both practice as well as participate for competitions. So first, to practice, you could go to this. There are a lot of sites like HackerRank, CodeForces, CS Academy Project Euler, CodeChef, and TopCode. So these are like the most famous one, but there are tons and tons of other ones as well. So I would suggest HackerRank as the best place to learn about algorithmic programming, because they have a very nice structured way to do this. So if I go to their particular website, so this is the HackerRank website. This is how it looks like. And once you go to this dashboard, you have this particular sector called practice. And below that, you can find a topic called algorithms. And in this algorithms, you can find various problems that they have listed. So these problems are separated based on the difficulty, like easy, medium, or hard. And they are also like separated depending on the subdomains, like string sorts, and then graph theory, greedy dynamic programming. So greedy is something that we discussed. Similarly, you can find lots of questions in them. And these are also arranged in a nice way so that once you start, you would start with the easy questions. And as you go on, you would encounter more harder questions. So, it would be a nice learning experience once you solve them one by one. The main issue or the shortcoming of HackerRank is that if you go to this example, you can see that there are problems and then it gives you a description of the problem. However, it doesn't clearly explain you what the solution is. Of course, you can go to this discussion part and then, read about what others say about this problem, or, you can check out this editorial as well. But sometimes it might not be clear, as in the algorithm itself won't be clear. So the problem setter might explain what algorithm you should use, but he would not talk about the algorithm itself. So in that case, a good place to learn about the algorithms is this website called Geeks. So over here, you have this particular topic called algorithms. If you go there, then they will list out many topics under which they have discussed many problems. So to explain an algorithm, they use this particular problems, and using the problems, they kind of explain how an algorithm works and how it can be used to solve particular problems. So just like HackerRank, Geeks or Geeks also has a downside. It's that the sections are not, although they are organized, you have too much data. I don't know if that makes sense, but like if you go to a particular topic and try to find the subtopics in there, as you can see, there are lots and lots of questions. So if you try to do all of them, it will be quite time consuming, and you'll get stuck in a particular topic itself. So the best way would be to first go to HackerRank and try to solve these problems. And once you encounter a problem, you can go to the discussion and then see what the others are talking about. So usually when you go through these explanations, some people directly post the answers, but some people, they explain about the algorithms that they have used to solve it. So they just say the algorithm name, and then you can come back to Geeks or Geeks and look for the particular algorithm that you need, and then click one of these links, and it will take you. It will take you to this page where it explains the algorithm much more clearly. So yeah, my advice would be to use a combination of HackerRank as well as Geeks or Geeks if you're a beginner trying to learn. But if not, like if you're a bit more experienced, then you could use any of these websites to improve your programming, algorithmic programming skills. These platforms also have competitions which takes place online. Apart from them, you have a lot of local competitions in Sri Lanka. So ACES Coders and Mora Extreme are two of the most famous ones organized by university students. In addition to this, as a university undergraduate, you could also participate in worldwide competitions like IEEE Extreme, Google CodeGen, ACM ICPC. Unfortunately, this ACM ICPC, it's only like right now, it's only available in person. So being in Sri Lanka, you might not be able to compete in this. And your easiest solution or the nearest solution would be to go to India and compete with Indians. However, IEEE Extreme and Google CodeGen are two of the well-known competitions, and they are available online. So IEEE Extreme is a group competition, whereas Google CodeGen is an individual competition. So you could participate in both of them and see where you rank when compared to the other people in the world. So finally, these are a few of the questions that are asked often. Due to the way these competitions are structured, most people think that to participate in this competition, you would need to be an expert, an expert in algorithms or expert in programming or an expert in mathematics. But in reality, most of them can be learned within a very, very short period of time. Of course, there's a slight learning curve, but if you are willing to invest some time into this could be done very, very easily. So my estimate is depending on your willingness to learn, you can do this in 3 to 6 months and become quite a good algorithmic programmer. Then there are some people. So if you have a question as to whether you have to be an expert in anything, my answer would be no to them. And then some people assume that you would have to be an expert in mathematics as well. Just to say something, that this is not a place to test your mathematics skills. This is a place to test your programming skills. So while you need simple mathematical knowledge, like maybe up to grade 9, 10, or maybe O-level knowledge, you would not have to know even things slightly complicated, like differentiation and integration. Those kind of problems usually do not appear in these competitions. So what you actually need is some amount of problem-solving skills and the will to learn. So anyone who is interested and has the will to learn can excel at this without having any prior knowledge on programming or algorithm and DS. All you need is some amount of problem-solving skills and a bit of perseverance, and within about 6 months' time, you could become quite a good programmer. So this is not based on personal experience, but from what I've seen from others, I can guarantee that 6 months would be a good a place where you can be a good programmer if you invest some time into this. Okay, now with that we are done with the break. We'll come back to the find sum problem. In this part, we'll be solving it using a technical dynamic programming. I'll just give a recap of the question first. So basically, what you are given an array A, and you need to find the sum of all the elements between indices P and Q, and you should do this Q times or Q queries. We saw that this particular example failed because in this case, the time complexity is OQN, whereas the maximum operations that we can do is Q into N goes to 10 to the power 11, whereas the maximum operation that we can do is 10 to the power 9. So why does this fail? That was our question. So if you see over here, we have Q number of queries, and each of these queries takes N number of steps. So we can't stop iterating through Q number of queries. So that's not an option. So there should be some way in which the sum array function can be optimized so that it doesn't take ON amount of time. So we will look why this happens. If you go look at this particular example where we have N equals 9 and 3 queries, and if we try to calculate the sum for this particular ranges, you can see that there are certain overlaps between these ranges. And as such, certain ranges, they get calculated multiple times. For example, this range 3 to 4, it's calculated 3 times. This range 1 to 2, it's calculated 2 times, and so on. So even for such a small test case, you have so many repetitions, and this is what's causing the problem. So if there was some way in which we can save all these pre-calculated values, and once you save them, you can reuse them, and once you have saved, it won't take ON amount of time to do those calculations again. So if we can find a way to do that, then we could maybe optimize this. Right now this part is ON. Maybe we would have an option to optimize it. So what I would like to do this is replace this sum array function, which calculates the sum between a particular range using a memory element. So we saw that there were we saw over here that there were a lot of intersections. So what we can do is we can find all this intersection and store it in this 2D array. So this 2D matrix represents the sum of all the elements from P to Q. For example, from 3 to 4, you can save all the elements or the summation of the elements in this box. From 1 to 2, the summation can be saved in this box, and as such. So now, since you have pre-saved it, all you have to do is just take them out from the memory and use them, and as such, it doesn't take as long as time. However, there's a problem in this one. First problem is that it's not possible to calculate all these intersecting values. That would actually take a much longer time than what we are doing right now. Number 2 is, like, if you observe this, this is an N into N matrix, and N is 10 to the power 4, which means to calculate all these values, you need to spend N squared amount of memory and N squared amount of time as well. So 10 to the power 8 is kind of a place where there's a probable chance you might fail, and especially in this question, if you try that, you will fail. So based on the way we have defined this problem itself, we cannot optimize it. And the reason for this is, like, if you analyze the reason for this, is like we have 2 variables which vary from 0 to n. This will lead to n squared amount of complexity, and we should find a way to redefine the problem somehow so that we don't have this problem anymore. So for that, what we can do is we can try to change this 2 variable function, the sum array APQ function. Now it has 2 variables. If we can convert into a single variable function, then all this, this would not go from n squared, this will only go up to ON. And once I try to save all those values, it will only take ON amount of memory, and it will be much more fast. So based on the redefinition of the problem, we can probably optimize it. So we believe that we can optimize it because as of now, since we have 2 variables, we cannot optimize it any further. So how can we redefine this, which would be our next question. So what if I, instead of using a 2 variables function called sum array A, P, and Q, what if I use a single value function sum AX, where it represents the sum of all the elements from 0 to X. So that is like if I redefine this, then I can say the sum between this point is the sum from here to here minus, like, sum from here to here minus sum from here to here. I can represent it as the difference of 2 summations. Like if I write it, so if sum AX is sum from 0 to X, then sum APQ, sum array APQ is the sum from 0 to Q and sum from 0 to P minus 1. So I can just take the sum from here to here and reduce the sum from here to here, and that would give me the sum from here to here. So by this new redefinition, we can write this particular function like this. So I can say sum array APQ is the new sum up to Q minus the new sum up to the P minus 1 point. So now we have redefined this problem so that we just have a single variable. So now there should be a way to optimize it so that we can do it in time and space. But if I just calculate all the sum values, for example, for some new A1, if I just take this sum, and some new A2, if I just take all the sums, it's still going to be inefficient. In space of time, it will still be ON, but in terms of time, it will be ON squared. So to optimize this, we use a slight trick in algorithmic programming, which we call DP. So explaining DP as it is, like step by step, it's going to be very complicated. So the short way of understanding is to convert a normal problem into DP. First, we should try to convert into a recursive function, and like if it's like a single value recursive function, then we can try to use a technique called memoization, and then solve the problem. So in this case, we have a single valued function, and as such, we can try to first convert into a recursive function and then convert it into a DP problem completely. So how would we convert it into recursive functions? That's our first question. So we noticed that to calculate the sum up to a certain point, what we did is we initialized a total variable called 0 and then added all the values up to end. However, like now, let's say we need to calculate the sum of the all the elements up to x plus 1 point. So what we can do is, instead of just taking the entire sum, I can say that this is the sum of all the values up to this point plus the actual value at this point. So if I just take this value and take this value and combine it, I can give it over here, and this would be the sum of all the values up to that point. So we represent it as a recursive function. So recursive function is a function which calls itself. For example, I can say sum new AQ is sum new AQ minus 1. So this is the sum of all the values up to point Q, and this is the sum of all the values up to point Q minus 1, and this is the value at Q. So the recursive function is a function which calls itself, and we have now converted this into a recursive call. However, there's still a single problem. Like if you're familiar with recursive function, you might know that you need something called a base case. So what a base case is, like if I call the function sum new A3, it's going to call, if I put 3 here, it's going to call 2. And then if I call 2 here, it's going to call 1. So it will go in this manner like this, behind and behind. And ultimately it will go sum new A minus 1, A minus 2. And so there should be a point at which I should stop this. So this is called the base case. So in our case, this sum new A0 would mean all the values up, all the sum of all the values up to the point 0. So in this case, that would be just this number. So this does exist. However, if I go to the next point, which is sum new A minus 1, there is nothing like that. So there is no A minus 1 element. So in this case, minus 1 is not defined at all. So as such, our base case would be that sum new A0 is equal to A0. So I can write my base case like this. So using this base case and recursive call, now I have created a recursive function. So next problem. So now I have completed the recursion part of this problem. Next, what I should do is memoization. So if I just write this recursive call as a function as pseudocode, I can write this like this. So if before I said anything for x, anything below 0, like x minus 1, it's not defined. So if x is less than 0, I just return the number 0. Else I call this recursive function itself. Okay. So next step is memoization. So this is not a spelling error, it's actually called memoization. So instead of a recursive call, but if we store all these values in a list, like memorize them. So in this case, the blue list would be the actual list, whereas the red list would store all the summation up to a certain point. For example, the summation of all the numbers up to point 0 would be stored here, which is what we call sum new A0, and the sum new A1 value would be over here, which would consider of this summation up to 0.1, and as so on. So at each and every point, instead of having this recursive call itself, we would have stored a particular value. So now, if I'm doing the recursive call, it would call behind and behind. So from x I would go to x minus 1 and x minus 2. So recursive call would be a bit time consuming. Whereas if I had pre-calculated and stored all these values in the memory itself, it would be quite easier. Like I can just take them from the memory in all one time. So if you remember from before, I can't just use the sum function to calculate values because that is going to be inefficient. But I can use this idea of the recursion for memoization. So I'll start with the base case. So as you might know, for the first element would be sum new A0, and the base case said that sum new A0 is equal to A0. It's over here. So sum new A0 is equal to A0. So I'll just put this value over here. So instead of 0 index, I'm just making a memory element where I put that value to the 0 index. So at the first index, what I do is I do the recursive call. So the recursive call says that the sum of all the elements up to the index 1 is equal to the sum of all the elements up to index 0 and the element at index 1. So the sum of all, so sum new A0 is over here and A1 is over here. So I'll just take these two values and add them and put it over here. Then for sum new A2, I need sum new A minus 1 and A2. So for this, I will need, if I can write this would be sum new A2 would be sum new A1 plus A2. So this is from this recursive call. So this value is over here, whereas this value is over here. So what I can do is I can just take these two values. Sorry, it's over here. I can just take these two values and add them and put it over here. So that's exactly what I'm going to do the next step. So I do that. So similarly, I just continue and keep on doing this until I reach the end of the list. And in n number of steps, I can find the answer. So previously, if I just do the recursive call, it's going to, for each element, it's going to take in number of steps. As such, the time complexity is going to be O(n) squared. Whereas if I just do this memoization technique, it will just take me O(n) number of times, because at each point, I'm just doing one summation operation. So if I write this as a pseudocode, it'll look something like this. So previously I had this recursive call, which keeps on calling, and as such it has an O(n) complexity. However, now if I just try to take this value, I'm just returning it from the memory because I have already calculated all of them, and now I'm just returning it from the memory. So now it would just take me O(1) amount of time. So now that I have made my function much more efficient, I can plug into the previous occasion. So previously, if you remember this particular function, it had a complexity of O(n). However, if I do this memoization earlier, the DP technique earlier, this DP technique itself would take in number of time steps. However, now when I call this function, the sum new function can do all this operation in one time step. If I go back, I can see that it just returns the from the memory. So the sum new function, the new one has O(1) time complexity, and as such, if I just call this now my code would be much more faster. So in this case, I'll have q iterations where for each iteration I do just one operation, and outside this iteration I have this pre-calculation where I do a number of operations. So now my time complexity has gone much lower. So initially it was q into n. However, since I do this pre-calculation, now it's q plus n. It's actually over here. So n into n plus q into 2. So out of both this, the worst case is q because q is 10 to the power 7, whereas n is 10 to the power 4. But yeah, something that you might have noticed is that to get this memory gain, so the time gain, you should sacrifice something. And in this case, we sacrifice a little amount of memory. So the pre-calculation step, this is something new, and this would take exactly a number of memory elements. And as such, this would be, in this case, we'll be using a slightly bit more amount of memory. However, we'll be saving a lot more time. So just to summarize what I did for this particular problem. So first I try to, brute force the answer. So brute force solution is where I just tried to get the sum by calling the sum function. However, that did not work. So then I found out the issue. The issue was that we had a multivariable function. So what I did is I tried to convert it into a single variable function. And once I have a single variable function, I can do this trick called DP, where I can use recursion plus memorization to make my calculation much more faster. So in this case, we used a technique called bottom-up. But there's another technique as well. So you can, if you want to learn more about DP, you can search this. But in this case, I was just using a trick to get the answer much more faster. So the hints from this problem is you can find, learn three main things. First is think of the complexity as a number instead of the big O notation. So I told you that 10 to the power 9 is like a limit for the time complexity, whereas 10 to the power 8 is like a limit for the memory. So you should try to make sure that the number of operations doesn't go beyond this limit. Next is look at the constraint to get an idea about the answer. I did indeed use this technique over here, because if you go over here, I know that I should definitely go through this iteration queue number of times. So there's no way I can skip it. So by looking at that, I kind of got the idea that this function should not be very heavy, this should not be a very heavy function. It should be a very efficient function. So as such, I did this pre-calculation before calling it, and then the memorization technique helped me a lot when making this decision. So the constraint might give you an idea about the ultimate answer as well. So then if you don't understand the question, you should look at the sample. So this is also something that I did, but in this question, it was not such a huge issue. But when you are moving forward, you might encounter questions where this happens. So with that, let's move on to the next question of the session. So the next question is a prime sum question, which is based on a mathematical algorithm. So we'll just go to the problem directly. So I'll not read through the entire question. So I'll try to summarize the contents of this question and what you're required to do. So basically, you are given an array and A, and you should find a particular point I such that the sum of all the primes on the left-hand side and the right-hand side are equal. To explain this, I'll just use a few of the sample inputs, and hopefully you'll understand what's required from this question. So first line contains an integer t, it's 3, and then each of the following, the test cases are explained by two lines. So this is the first test case, this is the second one, and this is the third one. And yeah, in the first test case, if you come over here, the first line explains the size of the array, and the second line gives the array itself. So in this particular array, there are 4 primes, 31, 3, 29, and 2, while 33 is not a prime. So if you are considering the sum of all the prime numbers on the left and the right side for each indexes, for example, I'll consider this first number over here, 33. If I consider sum of the primes on the left-hand side, it's 0 because there are no prime numbers on the left, whereas on the right-hand side, we have all 4 of them are prime numbers. So in this case, they are not equal. So obviously 33 is not the correct answer. Then if we go over here, 31, then on the left-hand side, we have 33. However, 33 is not a prime. So the sum of primes on the left is 0, whereas the sum of primes on the right is 33 plus 3 plus 29 plus 2, which is not 0. So in this case, 31 is also not the answer. When I come to 3, then on the left-hand side, I have 2 numbers, 33 and 31. Here, 33 is not a prime. 31 is the only prime. So the left prime sum is 31, whereas the right prime sum is 29 plus 2, since both of them are primes. So 29 plus 2 is 31, and also on the left hand, we have 31. So indeed, at this point, the left sum and the right sum are equal. So this could be one of the answers here. We can check this for the other 2 indices as well, but we will find that the left sum and the right sum of primes are not equal in both those cases. So for this particular first example, 3 is the answer. For the second test case, if you come over here, you'll have you have 2 numbers at this particular position. Okay, so sorry, 3 is the point. Sorry, I made a mistake there. 3 is the position of the answer. The answer that you should print out is the exact position. So in this case, the position of 3 is 2. So since you know that the array is a 0 index, so this is 0, this is 1, and this is 2. So the position of the answer 3 is 2. And that is what's printed out here. In the second test case, similarly, you have 2 numbers. And if you go to the first number, you can see on the left-hand side, there are no primes. And sorry, in the left-hand side, there are no numbers. Whereas on the right-hand side, there are no primes. So in this case, the left sum and right sum are both 0. when at this point 3. So the index of this point 3 is 0. So we print 0 as the answer. For the final case, we have 5 numbers, 2, 3, 4, 1, and 5. Over here, 2, 3, and 5 are the only prime numbers. And if you go over here, so there can be 2 answers for this particular example. So if you go over here, the sum of primes on the right is 5, and the sum of primes on the left is 2 plus 3, which is also 5. So this can be an answer. However, if you go here, you'll still see that the sum of primes on the left and right is still 5. So out of both of these, we choose the number 4 because it says the first index point is the answer. And the index of this number 4 is 2 because this is 0, 1, and 2. So you print a 2 over here. So this question is not that complicated. The basic idea is you are given a particular array I, and you should find a point I such that the sum of primes on the left and right are equal. Once I see this question, I would mainly have three main issues. First is how would I find primes? So still we don't know where to find primes, and if you don't know what prime numbers are, you could just Google search it. But basically, prime numbers are numbers which are only divisible by the number itself and 1. So for example, a number like 5, it's only divisible by 5 and 1, so it's prime. Whereas a number like 9, it's divisible by 1, 3, and 9. So 9 is not a prime, whereas 5 is a prime. So my first problem is how would I find these primes? My second issue is what would I do if there's a non-prime number? So when I encounter a non-prime number, it should not have any effect. So I have 2 options in this case. One is I can just remove the number itself. For example, if I find a non-prime number here, if I take this out of the list, then it won't have any effect on the summation. So I need to take the left and right summation, and non-prime should not have any effect. However, if I do that, then I'm going to make a tiny mistake, which is like the indexing of the array is completely going to change. For example, if I do this, remove this, then the indexing of this is going to go from 4 to 3. So I cannot go to that option. However, I do have another alternative, which is I can make this number 0. So once I make this number 0, the indexes won't change. At the same time, when I try to take the summation of this range, the particular number would not have any effect. So that is the one probable solution, and it should probably work in this case. The final issue is I need a way to find the sum of the elements on the left and the right of the point. So if I consider point I need to find a way to find the left sum and the right sum. But if you remember from our previous example, we discussed a way where we can do this faster using this function called SUMNew. And by calling this, by pre-calculating it using a technique called dynamic programming, we can do it in O1 number of steps, O1 step. So there are many other ways to do this. However, since we already have the solution for this, I will not go deep into this because our main concern in this problem is finding primes. So if I write this in words, this is how I can say this. So first, I go through the entire list and find if a number is prime or not. If the number is not a prime, then I make it 0 and then continue to the next step. Then I iterate through the entire list, and for each point I try to find the sum of all the numbers on the left and right. Now, since I made all the non-prime numbers 0, I know that only the sums I'm getting are only the sums of primes. So I can get the sums of primes on the left and right using the dynamic programming technique that we discussed earlier. And if those numbers are equal, then the I would be the answer. So if I find a point like that, then I can just return the index of that point. If not, I move to the next point and I keep continuing doing this until I reach the end of the list. And at the end of the list, if there are no answers, then I can return -1. So if I write this as a pseudocode, it will look something like this. So this part is exactly the same. So first I read the number of test cases. Then for each test case, I read the particular list called A. Then I try to get the answer for this problem using this prime sum function there, which I pass A. So now this prime sum function looks something like this. So for each element x in A, I first try to see if x is a prime or not. And if x is not a prime, I make it 0. So still I don't have a way to do this, but for the time being, we'll just skip this and move forward. Then we'll calculate this value called sum A, which is from the previous example. If you remember, it's from the dynamic programming example. And after calculating this, then I can just find the left sum. So I iterate through the list and I can find the left sum and right sum by calling this particular function sum new. So to find the left sum, I can call it from 0 to the Persian I minus 1. And find the right sum, I can call it from Persian I plus 1 to n minus 1. So that's what you see over here. So using that technique, I can find the left sum and the right sum. Then I check if the left sum is equal to the right sum. And if so, I can just return the value I, because I need the first occurrence at which it happens. So this would not be the actual value I, but exactly the index of I. And finally, after going through all the I numbers, as in if I go from 0 to n minus 1, if I don't have an answer, I can just return minus 1. So now my exact problem is, how would I find if a number is prime or not? So I should iterate through a list and find if a number is prime or not. So that I can use the definition itself. So the definition says that if a number which has no divisor other than 1 and itself, then it's a prime. So what I can do is I can check all the numbers from 2, because it's obviously every number is divisible by 1. So I start from 2, and I can go up to n, and then try to find if it's divisible by any of the numbers. And if it is divisible, then definitely it's not a prime, because prime can only be divisible by 2 numbers. Ultimately, once I reach the end, if I still know that it's not divisible by any other numbers, I can say, yeah, true, it is indeed a prime. So I can write a pseudocode like this. So this is a function to find whether number A is prime. So for all the numbers I between 2 and square root a. So yeah, something that you might notice here is you don't need to actually go until A. You can stop at square root a, because if a number is not divisible by any number between 2 and square root a, then definitely it might not also be divisible by any number above that. So in that case, I can just stop at square root a and say whether it's a prime or not. So I just go from 2 to square root a, and I try to find if a is divisible by that particular number. So I is this number between 2 and square root a, and if it's divisible, I can directly say that it's false. However, after trying all these values, if it's still not divisible, I can say that it's true, it's a prime number. So if you look at the time complexity of this would take exactly square root a number of steps, so square root a minus 1. But if you are looking in terms of time complexity, it's like O square root a. So if I plug this into the equation that we discussed before, so over here we have the function to calculate prime sum. So the first step is I iterate through the entire list to find if it's a prime number. So iteration takes exactly n steps, and for each of these elements, finding if that particular number is a prime, it takes square root a. So the difference is like n is the size of the array, whereas A is the maximum value of the value of the maximum number in that array. So in the worst case scenario, if I had all thousands, then for each of this element, I need to do square root 1000 number of steps. So this particular iteration, it will be n into square root a. Then we have the pre-calculation step over here. This can be done in n number of iterations. You can just go back and check exactly what it was. Then for each index I from 0 to n, I check the left sum and right sum. So this is an n iteration. However, every step inside this, the left sum and the right sum steps, this just takes one operation. So this entire thing, it would take something like 3 operations, but in terms of O, it's O1. So over here, the complexity of this entire part is O1. The complexity of this pre-calculation is this is On, this is On. However, this iteration part, it has n into square root a number of steps. So ultimately, if you consider the time complexity of the entire function, it would be n square root a plus n plus n. So ultimately, n square root a is a much bigger value. So n square root a would be the complexity of the entire function. So if you consider the function prime sum, then the time complexity would be n square root a. However, now we'll be doing this again and again for test cases. So ultimately, I would require t into n into square root a number of steps. So now, next we know what we should do to check whether this would work. I'll just go back to the question and check the numbers actually. So the complexity, the time complexity was t into n into square root k. So this is 100 into 10 to the power 5 is 10 to the power 7. And square root of 10 to the power 6 is 10 to the power 3. So 10 to the power 7 into 10 to the power 3 is 10 to the power 10. So 10 to the power 10 is much more than 10 to the power 9, the limit that we have discussed up to this time point. So as such, we know that this solution would not work. So next so what we do next is we try to find the bottleneck of this problem. So bottlenecks is like the particular function or call which makes this worse. So in this case, the first call over here is that we repeat for each number n, we repeat this time function n number of times, and it will take square root a number of times. Sorry. So to solve this, there is an algorithm called sieve. So the sieve algorithm can be used to find all the prime numbers up to a particular number n. As you might know, sieve is the instrument that we use to separate solids from liquids. For example, while making tea, to separate the tea leaves, we can use a sieve. So similarly, sieve in mathematics is something that we can use to find all the prime numbers up to a particular number n. So if you want to learn more about the sieve, you can just search in the Google as prime sieve or something, and you'll probably get the answer. So yeah, I will explain how we do the sieve next. However, if we look at the time complexity and space complexity, so first to find all the prime numbers up to n without the sieve, as in using the previous technique I mentioned out here, it would take n into square root n number of numbers, because you have n numbers and you should do square root n number of operations. And if I do it with sieve, it will only take O n log n log n number of operations. Sorry. So it will take n log n number of operations. So numerically, it's always easier to us to think with numbers. So if n is 10 to the power 6, so in our case, a was 10 to the power 6. Without sieve, I will use 10 to the power 6 into 10 to the power 3, which is 10 to the power 9 number of operations. Whereas with sieve, I will only need 5 into 10 to the power 6 number of operations. So this is like a 100 or 200 increment, which would be significant when it comes to our problem. Something you might have noticed is that you cannot gain time without making any sacrifices. In this case, the sacrifice that we'll be making is we'll use a memory element to store all these prime numbers. So as such, the space required would increase to O n. But O(n) is not a huge issue in our case. Yeah. So this is how the sieve works. The pseudocode for it is over here. So what we do is we do the initial iteration from, if I want to find all the prime numbers up to the number 50, I start from 2 and go up to root of 50. So this root is kind of special because after this root 50 values, we will not have any other, non-primes remaining. So in this case, the starting point is 2 and the ending point is root of 50, like 7 point something. So we'll just stop it at 7. And so we'll first do the outer loop. And then for each number in that list, if it's not a prime, then I do hops and start cancelling. So the first number itself, it's not cancelled yet. So that is indeed a prime. And then we start hopping from this number. So I go from n to n squared. And then at each step, I hop by n. So I start from 2 and I go to 2 squared, which is 4. I cancel it. Then I go 2 more to 6. I cancel that. Then I go to 8 and cancel that. And so on. I can cancel all the numbers up to 50. So if I cancel all the numbers, it will look something like this. So once I'm done with this, I will go to the next number, which is not cancelled, which is 3. So from 3, I will make the first jump to 3 squared, which is 9, and I will cancel it. And then from there, I can move to, so 9 plus 3 is 12, then 12 plus 3 is 15, 15 plus 3 is 18. And as such, I can keep on cancelling these numbers. Then I go to 4, and then I go to 5. 4 is already a non-prime, so I don't need to consider that. So 5 is still not cancelled, which means 5 is a prime. And I can keep on doing this. So if I just implement this algorithm for all the numbers between 2 and 50. Sorry, I missed one number over here. So this, so the last number is 7, and 7 squared is 49. So it brings us over here, and this would get cancelled. So once I do it up to 7, which was our endpoint, I would see that all these numbers have been cancelled. So in this case, all the cancelled numbers, they are non-primes, and all the non-cancelled numbers, they're prime. So if a number is white over here, then that's definitely a prime. So if you are still not clear about this, you can just search for prime sieves in Google. So this is just one implementation of sieve. There are many other implementations with different complexities. And analyzing the complexity of this algorithm is a bit complicated. So we'll just think for now that it's always, a log a. So now, if I just plug this inside my function, so previously, if you remember, we had the prime calculating function over here. So yeah, so previously this had a complexity of square root a. However, now since I already calculated these prime numbers, before using this sieve, I can take this prime calculating out of this particular function and now put it over here. And due to this reason, my complexity of this particular operation, this becomes 1. So I have significantly reduced the complexity of the prime sum function because now it's n into 1 plus n plus n. So the total complexity of this particular function is O(n). So now I know that this is O(n), and the outside we have a log a. And then we'll be doing this again and again for t number of times. So if I look at the total time complexity, I have t number of test cases, and for each of them, I will do a log a number of operations. So we saw that log a is somewhere around 5 for 10 to the power 6. So I'll just put that here. And so this is the prime number calculating operation, and then this is the operation that finds the actual answer. So overall total, if we see this value, this would make up 10 to the power 7. Whereas this would make up 10 to the power 8. It's actually 5 into 10 to the power 8. So in this point, we are kind of in a icky situation because at 10 to the power 9, our algorithm will definitely fail. We know that. So this might work, but there are cases in this might fail. So if we kind of look at the problem, there is still one place where we can update it. For example, why are we calculating this value again and again? Because prime numbers are always going to be constant, right? It's not going to change because of the test case. So what we can do is we can take this particular operation, and if we bring this outside, outside of these test cases, because prime numbers are always constant, I say. And if we do that, then ta-da! So we will have this a log a term outside. So previously, if you see this for each test case, we are calculating this. We have this 5a term. However, once I do this, t would not have any effect on this, a. As such, the complexity would reduce significantly. To be exact, this would be now t into n. So this is t into n plus a log a. So t into n is 10 to the power 100 into 10 to the power 5 is 10 to the power 7, plus 5a is 5 into 10 to the power 6. So ultimately, the total time complexity would be somewhere around 10 to the power 7. So 10 to the power 7 is still less than 10 to the power 9, which was like the limit that we learned before. And one part you might be wondering is like, what's the maximum value of a? And so now if we go to the constraints back again, we can see that a is 10 to the power 6. So this is the maximum value of the prime numbers. So you can try this algorithm by yourself if the implementation of the sieve is already in the problem. So I have posted the link, the Geeks link there, so you can just copy and paste it. But the rest of the things you can do that by yourself, probably. So the hint for this particular problem is that you should always try to calculate all the concept values even before starting the problem. So for example, in this case, prime is always constant. It's never going to change. So if you just calculate it and keep in the memory, then you can reuse it whenever you want. So we'll have to end the session with this question due to limited time. So the next problem is number pyramids. So I'll give you a hint of solving this. This is a challenge for you. You should solve this using the same technique that we did for the previous question. As in, first you can try to brute force it. Then you could, from the brute force, you could jump to the recursive solution, and then you could try to optimize it through dynamic programming. And using these steps, you can actually solve the problem. So with that, we will end this session and move on to the question and answer. So now we will go on to all your questions in the discussion, as well as, we'll try to answer all the questions that you have.
Thank you very much, sir. So it's time to move on to the Q&A session. So I kindly invite all of you, if you have any questions regarding the session or if you have anything to clarify, make sure to drop your question in the link in the chat box. So if someone has submitted the same question, please vote that question without submitting the same question again. So let's take a look at the questions. So far we have only received one question. So the question is, what kind of advantages do we get when applying for jobs if we have participated in many coding competitions?
Okay, so hello, can you hear me? Yeah, okay. So I think I already covered this somewhere, but I don't think if I can share my screen, but okay, never mind. So the main advantage is that it will be a great addition to your CV. For instance, as I said, one thing is like Google and FB, they have their own coding competitions. So if you participate in them, then you'll have a very high chance of getting into such companies. And, even if not such companies, then definitely Sri Lankan companies, they will consider it to be a huge addition. It doesn't have to be something complicated like, Google or the FB hacker challenge, but you could also do the local competitions like ACES Coder. So more extreme, like these are very high ranked competitions in Sri Lanka. So the companies that hire, they usually look for top programmers from this kind of competition. So definitely you would have comparative advantage compared to other interviewees. But also there is another thing that usually goes unsaid, because some companies, they do indeed use your problem solving ability to test how good you are, obviously, right? So this algorithmic programming problems, this is like common way to test your ability during this interview. So even before you come to an interview, what people usually do to weed people out is that you'll be given a programming assignment and you'll be asked to solve them by yourself. So in that way, the interviewers, they think that they don't have to waste time on a lot of people. So this is kind of the first filtering step, and if you are familiar with it, then it will definitely be more advantageous. So just to give you an example, if you are going to get hired to Google, definitely your second interview would be the first interview itself would be some kind of coding practice, and the second interview is, I think, a coding challenge, which you should do it online as the person checks it. Similarly, there are a lot of other companies in Sri Lanka as well who use coding. All these coding platforms are a great way to test your knowledge. I won't tell the exact names, but one of my friends is doing his interview next weekend, and he also has to do this online coding interview thing. So definitely, if you are familiar with these questions, like even if you don't rank top in them, if you are familiar with them, definitely you will have a competitive advantage compared to others who are coming to the interviews. So as such, it would be, even if you don't excel at this, it would be always advantageous for you to do these kind of questions. Thanks.
Thank you very much, sir. So that's all the question we have received so far. So eventually, moving on to the conclusion of today's session, I would like to take this opportunity to appreciate our resource person for today's session. So Mr. Suren Sitaran, thank you very much, sir, for your delivering us such a great session of algorithmic programming and coding competitions. And also, thank you very much for the advices you have gave us throughout this workshop series. So I would like to give this token of appreciation on you on behalf of the IEEE Computer Society's student branch chapter of SLTC. So I kindly request you to accept this token of appreciation.
Yeah, thanks for this. So I'm just glad I got the opportunity to share some of my experience, and I hope that today's session, it was somewhat helpful for anyone who's trying to get into algorithmic programming. I would like to also thank the participants in this session who engage in all these activities, and there are some people who ask some questions as well. So this gives me some kind of food for thought of how I can make my delivery better next time. And apart from this, definitely I should thank the IEEE Student Society branch of SLTC for organizing this CodeGeniX event, because this is a kind of new experience to me. The purpose of this program, as it seems, to give you an intro to myriad of fields rather than focusing on one topic. So it's like a wine tasting. You might love Chardonnay, but when you go to wine tasting, you would get the opportunity to taste other things like Pinot Blanc or Pinot Noir. So similarly, I hope that this session, it kind of gives you this idea of wine tasting, where I can get a taste of everything, and it helps you find your passion. So as the last step, I would also like to thank the IEEE Student Society of SLTC
for giving me this opportunity, to be a part of this. Finally, if you have any other questions, do feel free to post them in the discussion, or you can even contact me personally. So my mail is surenes@sltc.ac.lk, and you can contact me if you have any issues regarding this. So thank you very much for everything.
Thank you very much, sir, for your valuable words. Okay, so that's all about the session. And I would like to thank all the participants for being with us for the whole Python workshop series. And I hope you'll stay with us for the rest of the sessions in the month of CodeGeniX. So just to let you know, there will be a webinar on Introduction to Machine Learning, which is known as ADAGRAD, will be held on 5th of June at 3 p.m. onwards. So all of you can join that as well. So another industry expert in machine learning will be joining us on that day. So let me repeat the date, 5th of June, 3 p.m. onwards. So that's all about it, and stay tuned and hope to see you all in the upcoming session. Until then, have a good day. Good night.